Okay, guys, so the next thing I would like for us to look at is integration using algebraic substitutions. Now, with algebraic substitutions, the substitutions usually made is basically to let u be equal to f of x, to let u be equals to f of x such that fu du is a standard integral, and it is found in integrals of the form k f of x raised to power n and f prime of x dx, and integrals whereby you have a function down here is raised to power n, and on top you have its derivative. So you have a function, and besides it you have its derivative, or you have a function down here, and on the numerator you have its derivative. Now let's look at a few examples and see how exactly we go about this. Let's say you're given a question like this: integrate cos 3x plus 7 dx. Now, clearly, as we can see from the table that we were given the standard integral of integrating cos ax dx. But now we have cos ax plus some c. So how exactly do we go about that? So we are going to let u be equal to 3x plus 7. Then write the whole of this question in terms of u. Now, if u is 3x plus 7, what is du dx? Du dx is equal to what? 3. Okay? So we are going to rewrite the whole equation by replacing the values of u with x. So what will that translate to? So rewriting this equation, we will have integral of cos. Now, instead of 3x plus 7, we will write u. And instead of dx, we will write du. So make dx the subject of the formula here. It will be du over 3 is equal to dx. So here we will have du over 3. This is basically 1 over 3 integral of cos u du. Now it is in the standard form. This is 1 over 3. The integral of cos u is sine u. Okay, so this is our answer plus c. But what is sine? What is u? U is 3x plus 7. So you have to rewrite back u into its initial form. Sine 3x plus 7 plus c. That's how you go about integrating using algebraic substitution. Let's look up at another example. So you're being told to integrate 2x minus 5 raised to power 7 dx. So let u be equal to this that is inside here. So let u be equal to 2x minus 5. Then what is our du dx? Differentiating this, we get 2. So we are going to rewrite this equation, all of it in terms of u now. So this will be the integral of u raised to power 7. What is dx? Dx is the same as du over 2. So this is du over 2, and this is a half u raised to power 7. If you integrate, you get u raised to power 8 over 8 plus c. But what was the value of our u? You write it back. So this will be 1 over 16. The value of u is 2x minus 5, and it is raised to power 8 plus c. So that's it. That's how we go about integration using algebraic substitution. Example number 3, we have 4 over 5x minus 3 dx. You're being told to integrate this. Now, we will let, clearly, if you differentiate 5x minus 3, you will get 5. But here we have 4, which is a constant, but we can be able to manipulate this so that it gives us a 5. Anyway, let's let u be equal to what is down here. So let u be equal to 5x minus 3. Now, what is du dx? Du dx is 5. Let's rewrite the whole of this equation. So we have 4 over, this is u. Instead of dx, we will have du over 5. du over 5. So this is basically 4 over 5 integral of 1 over u du. This is 4 over 5. The integral of 1 over u is ln u plus c. But now we need to write it back in terms of x. So this is basically the same as 4 over 5 ln. The value of u is 5x plus 3 plus c. Let's take up another example again. So example number 4. Example number 4. So let's have integral from 0 to pi over 6 of 24 sine 2 pi 5 of theta cos of theta d theta. Clearly, if you differentiate, so this is in the form, the standard form that we wrote here for algebraic substitution, you have f of x n and f prime of x, basically. So like this is f of x n and this is f prime of x. Okay, fine. So we are going to rewrite this as integral of from 0 to pi over 6 of 24. This is the same as sine theta raised to power 5 cos theta d theta. So carry out the substitution. Let u be equal to sine theta. Let u be equal to our sine theta. Now, if u is sine theta, what is du d theta? Differentiate sine theta, you will get cos theta. Okay, so come and rewrite this equation, all of it in terms of u. This is what we are going to have. So this will give us integral from 0 to pi over 6 of 24. Instead of sine theta, we will have u raised to power 5 cos theta multiplied by d theta. But what is d theta? If we make d theta the subject of the formula, d theta will be equal to du over cos theta. So d theta is du over cos theta. And this cos theta cancels with that, so that we are integrating from 0 to pi over 6 of u raised to power 5 du. And this basically gives us u raised to power 6 over 6, and the integral is from 0 to pi over 6. However, what was the value of our u? Our u was sine theta. So write back your answer. So this will give us sine theta raised to power 6 over 6. We are integrating from 0 to pi over 6. Then you can be able to replace our ranges and evaluate. So this will basically give us, so replacing with pi over 6, pi over 6 is just the same as 180 divided by 6, so that's 30 degrees. So we have a sine of 30 degrees raised to power 6 over 6 minus, replacing with 0, we have sine of 0 raised to power 6 over 6. So this will just give us sine 30 degrees raised to power 6 over 6, because the other side will be 0. So you can evaluate that in the calculator. Okay, final example of algebraic. So let's say you're given, so integrate 3 exponential 3 theta plus 5 d theta. So I am going to let my u be equal to this here. So let u be equal to 3 theta plus 5. What is du d theta? Differentiating this, we get 3. So I'm going to rewrite the whole of that equation in terms of u. So I have integral of 3 exponential u. What is d theta? D theta is the same as du over 3. So this is the same as this 3 can cancel with this. I have integral of exponential u du, and integral of exponential u is exponential u plus c. So this is exponential. What's the value of our u? 3 theta plus 5 plus c. And that's our answer. That's how we go about integration using algebraic substitution.